Hello again. All right, so with 4D, we're going to be talking about parallel and perpendicular lines and equations. So for this top part, this is kind of a recap of what we did in 4A, B, and C. So with slope-intercept form, point-slope form, and standard form. So given that the linear equation has a slope of 3, and it passes through the point -1, 5, we want to write the equation in all three different forms. So for point slope form, this is typically the one that you want to start with for any and all equations. So if we have a slope of 3 and it passes through -1, 5, make sure that's actually the point. Yep. All right, so point slope form, y minus y1 equals m times x minus x1. All right, so y minus 5 equals 3 parentheses x minus -1. So that's going to turn into y minus 5 equals 3 parentheses x plus 1. So there is our point slope form. So now let's convert it to slope intercept form. So in order to do that, I'm going to take my equation from point slope form and just convert it and solve for y. So I'm going to distribute. So I have y minus 5 equals 3x plus 3. And then I want to add 5 on both sides. So I have y equals 3x plus 8. So there's my slope-intercept form. All right, so now I want standard form. So I'm going to take the exact same equation from point-slope form. Now I want to convert this. So notice how we're starting with point-slope form for both of these equations. Point-slope form is going to be one of your best starting points. All right, so I'm going to do the same step as before. So I'm going to distribute. So 3x plus 3. All right, so now I want my x and my y values to be on the same side. So your a value has to be a positive whole number. So we're good there. So that means this positive 3x is going to be my pivot point. So I'm going to subtract y on both sides. So I have negative y equals 3x minus y plus 3. All right, now I'm going to subtract 3 on both sides. So I'm going to have negative 8 equals 3x minus y, and then I swap it around. So 3x minus y equals negative 8. So this is my equation. All right, so now let's say I plotted all three of these on a graph. So if I plotted all three of them, all three of these lines are going to be overlapping. So because they're overlapping, that actually means that all three of those different equations represent the same exact line. So even though I have it written in, say, point slope form, slope intercept form, and standard form, if they're overlapping, there are three different forms representing the same equation. So they're going to be overlapping. So that's also a really good way to check to see if your equation is right in Desmos. All right, so now we're going to look down here at multiple different lines. So we're going to look specifically at parallel and perpendicular. So if you think back to the definition of parallel, parallel means two equations will not intersect at all. So on a graph, that means we're looking at two equations that are going to be increasing or decreasing at the same rate. And then we have our other new term, well, maybe not new, it's called perpendicular. So perpendicular means they're going to intersect at a right angle or at 90 degrees. So you're going to find new definitions and new postulates, axioms, and whatnot when you get to geometry. But we are going to cover a little bit of it here in algebra. So on a graph, if the slopes are the same, they're going to be parallel. But if slopes are what we call opposite reciprocals, then they're perpendicular. So we're going to look at the slopes of these lines first. So if I'm looking at line A, all these points are already here for us. So if I go up 1 over 1, so that means our slope of line A is going to be 1/2. And over here, if I look at line B, same thing. up 1 over 2, which means we're going to have a slope of 1/2 as well. So if you notice, line A and line B, they have the same exact slope, and they never intersect, which means A is parallel to B because the slopes are the exact same. So now let's look at line C and line D. So line C is right here. So it's going up 2 and then right 1. So this equation is going to have a slope of 2. Now line D over here is the one that is decreasing. So it's going to be going down 2 and right 1. So remember, you don't need any specific points to find the slope. I'm just finding 2 random points on that line and finding the slope. So for line D, we have a slope of -2. So if you notice, line A and line D are perpendicular, and then line B and line D are perpendicular. So they are opposite reciprocals. So another way of saying opposite reciprocals is flip the sign. Nope. So that's what we mean by opposite. And then by reciprocal, what we mean is flip the fraction. So flip the sign, flip the fraction. That's what opposite reciprocal means. So we're going to get more into that here in a little bit. All right, so in order to determine if lines are parallel, we're looking at the slopes, and the slopes must be equal or the same. However, the y-intercepts, they cannot be the same, because if you have the same slope and the same y-intercept, those are just 2 overlapping lines, which those aren't parallel because they can't intersect. Now for perpendicular, the slopes have to be opposite reciprocals, and the y-intercepts, those can be the same. They can be different, they can be the same, it doesn't matter. All right, so we're just going to do some practice in determining what a parallel and perpendicular slope is. So for parallel is always the same slope. So there's no change. So what that means is if I have a slope of 2, a parallel slope is 2. If I have a slope of 3/4, parallel slope is 3/4. Parallel to -4 is -4. Parallel to -1/2 is -1/2. Parallel to 0 is 0. Parallel to undefined is undefined. So it's the same exact slope. Now for perpendicular, that's where we take the opposite and we flip the sign, flip the fraction. So if you remember, so 2 is the same as 2 over 1. So I want to flip the sign. So it's going to go from positive to negative. And then 2 over 1, if I flip it, it becomes 1/2. So our perpendicular slope is -1/2. So similar situation with our 3/4 here. So if I have 3 over 4, I want to flip the sign. So it goes from positive to negative. And then 3/4, I flip it. So it goes from 3 over 4 to 4 over 3. So that would be my perpendicular slope. All right, so for -4, I have -4 over 1. So that's going to go to positive 1/4. So negative to positive, 4 over 1, it's now 1 over 4. So it flips. All right, then -1/2, opposite reciprocals, +2. Now, these last two are a little bit more tricky. So the perpendicular to 0 is actually undefined, whereas the perpendicular to undefined is 0. So these are your Hoybuck's problems. So down here, just to make it clear, these are your Hoybuck's. So with 0 slope and undefined slope. All right. So now looking down here, nope, I never got rid of any of that. These need to go. Okay, so with these 4 problems right here, I give you 4 different equations, or 4 different sets of equations. And you are supposed to tell me whether these lines are parallel, perpendicular, the same line, or if they just intersect. All right, so for parallel, remember the slopes are the same, and then the b values are different. Whereas perpendicular, the slopes are opposite reciprocal, and the b values doesn't matter. So if it's the same line, that means the slopes are the same, and then the b values are the same. And then if it's intersecting, that means their slopes are different. And the b values are also different. All right, so just kind of a quick reference for you. So this is actually really useful for you to have on hand. So just know for perpendicular, it just doesn't matter. So it doesn't matter. Okay, so notice how I wrote it in terms of the slope and the y-intercept. So I'm going to make sure all these equations are in slope-intercept form if they're not already. All right, so looking here. So the first equation here, we have y equals 4x minus 5 and y equals 4x plus 5. So the slopes are the same. However, the b values are different. So if the slopes are the same and the b values are different, that means these are going to be parallel. All right, so looking at the second one here, notice how the slopes and these are in point slope form. Notice how the slopes are the same. So that means these equations are either going to be parallel or they're going to be the same line. So we just have to determine whether the y-intercepts are the same or different. So I'm going to convert both of these to slope-intercept form. So I'm going to do this one over here on the side. So y minus 4, I'm going to go ahead and distribute the 2. So 2x plus 6. So add 4, add 4. So y equals 2x plus 10. So that's the first equation. So I'm going to do the other equation over here. So y minus 6 equals 2x plus 4. That's not a 6. There we go. All right, add 6. So we're going to have y equals 2x plus 10. So y equals 2x plus 10, y equals 2x plus 10. These are the same line. All right, now over here. So our second equation here is already in slope-intercept form. So y equals negative 1/3 x plus 2. I'm going to leave those alone. So I just need to convert the 6x minus 2y equals 6. So one thing you can do for this one is you actually can just do the trig. So the slope is the opposite of a over b. The x-intercept, which is c over a, and the y-intercept, which is c over b. All right, so my slope is going to be the opposite of 6, so negative 6 over negative 2, which is a positive 3. So if you look here, positive 3 and negative 1/3, those are opposite reciprocals. So these could either be perpendicular or they could just be intersecting. Actually, no, I take that back. These have to be perpendicular. All right, so we're going to check the y-intercept just in case, although the y-intercept doesn't matter. So we already know these are going to be perpendicular. So I know it's going to be 6 over negative 2, which is negative 3. So the slopes are opposite reciprocals. Y-intercepts, doesn't matter. So I know these are perpendicular. Perpendicular takes like 20,000 years to write out. I don't know why. All right, and last but not least, so our top equation here, y equals negative 2x plus 3. So this is written out already in slope-intercept form, so I just need to convert the second equation. So y minus 5 equals 2x minus 2. So I'm going to add 5. So y equals 2x plus 3. So looking at the slopes here, so we have negative 2 and a slope of 2. So they're not the same, so they're not parallel. They're not opposite reciprocals, so they're not perpendicular. They're not the same slope, so they can't even be the same line, which means they are just intersecting lines. They're nothing special. All right. So the slopes play the biggest role in this. So really be careful with parallel and the same line. The y-intercepts make a big difference there. Okay, so now we want to be able to write the equations of a line in slope-intercept form that passes through the given point and is parallel to the given graph. All right, so I give you the point that it passes through, and I give you the equation. So notice how it's in standard form. So I'm going to start with A, B, and C. So I know my original slope is the opposite of A over B. So negative 5 over negative 2, which simplifies to positive 5/2. So that's my slope. But now I want a parallel slope. So I'm going to shorthand parallel, and I'm going to start using the symbols. So the symbol for parallel is just railroad tracks. It's 2 lines. So the parallel slope is the same slope, so I'm still using 5/2. All right, so now I have the parallel slope. So I have my slope, and I have a point that my equation is going to pass through. So I'm going to use both of those values and start an equation in point slope form. So 2, 9, so I'm going to have y minus y1 equals m times x minus x1. So y minus 9 equals my slope, which is 5/2, and x minus 2. Now I want the equation to be in slope-intercept form, so that means I have to convert. So I'm going to distribute that 5/2. So I'm going to have 5/2 x minus 5. Now, if we want it in standard form, then we multiply everything by 2. But because we're in slope-intercept form, we don't have to. So now I'm going to add over the 9. So I have y equals 5/2 x plus 4. So here is our slope-intercept form equation. All right. All right, so now for the next one, same idea, but now instead of parallel, now we want perpendicular. But now I gave you the equation in slope-intercept form. So our original equation has a slope of 2/9. But for perpendicular, you have to take the opposite. So you have to flip the sign, flip the fraction. We want the opposite reciprocal. So a perpendicular slope, so the symbol for perpendicular is an upside down capital T. So I'm going to have negative 9 over positive 2. All right, so now, once again, start in point slope form. So y minus y1 equals m times x minus x1. So y minus negative 13 equals negative 9/2 x minus 6. All right, so now I'm going to keep simplifying. So I'm going to have y plus 13 equals negative 9/2 x plus 27. So I went ahead and distributed. All right, so now I'm going to write my equation by subtracting 13. So I'm going to have y equals negative 9/2 x plus 14. So there's our slope-intercept form. So the big idea here is just recognizing when to keep the slope the same and when to do the opposite reciprocal. That's really the only new thing that we're doing. Everything else is using point slope form or standard form or whatever that we've already done. Okay, so now we're going to do kind of a Hoy-Buffs problem, just so you can kind of see what that looks like. So writing the equations of a line in slope-intercept form that pass through the given points. So here's the original equation, just y equals 3. So this is the same as writing y equals 0x plus 3. So this is a Hoy problem since it's a y equals. So it's going to be a horizontal line that passes through 3. So down here on the graph, I'm going to go ahead and draw my original line. So this is y equals 3, the original. All right, so now up here, now we want to do something parallel through 5, 6. So remember, parallel means the same slope. So if my original slope is 0, that means my parallel slope is also going to be 0. So I want another y equals equation. So I want to take the y value of my coordinate, and that's my equation. So y equals 6. So now I'm going to go down here. So here's my parallel line that passes through 5, 6. All right, so I wanted it parallel passing through that specific point. So that's my new equation, my parallel. Oh no. There we go. All right, so there's parallel. Now I want perpendicular through 7, 8. So 7, 8. So here's 7, 8. And I wanted perpendicular through that point. So perpendicular means the opposite reciprocal. So if my original slope is 0, that means my new slope is undefined. Which means now we're looking at Bucks. Because before we were looking at Hoy. So I want the x equals value. So I'm taking the x value, and that's my equation. So x equals 7 is my new equation. All right. There we go. All right, so now we have parallel lines. So this is some geometry notation for you. So what I'm going to do here, so this symbol and this symbol mean that those would be parallel. So they're kind of like carrots, almost, little carrot keys. So those mean parallel. And now for perpendicular, you're actually going to draw a little box to show a right angle, which means that those would be perpendicular. So just some notation for you. All right, so now down here, this is where like the heart of the lesson is. So given the equation below, we want to find the equation and graph all 3 equations. So here's the original. So what I'm going to do is I'm going to find the slope, the x-intercept, and the y-intercept. So I know my a value is 4, b value is -3, and my c value is 12. So I'm really going to use this as the base information for everything I have below. So I know my slope is going to be the opposite of a over b, which is going to be -4 over -3, which simplifies to 4/3. All right, now my x-intercept is going to be c over a. So 12 over 4, which simplifies to 3, which would be 3, 0. Now for my y-intercept, now we're looking at c over b, which would be 12 over negative 3, which simplifies to negative 4, which would be 0, negative 4. All right, so what I'm going to do is I'm just going to plot just my two intercepts, my x and my y intercepts, and literally just draw the line between those. So this is going to be my original line. So 3, 0, and 0, negative 4. So this is my original line. So this is the basis of what I'm going to be working with. All right, so now for this first part here, I want something parallel. So this means parallel to railroad tracks. Parallel through 1, 2. So if my original slope, was it 4/3? Yes, is 4/3. That means my parallel slope is also going to be 4/3. So I'm going to start with point slope form. So y minus y1 equals m times x minus x1. So I'm going to do y minus 2 equals 4/3 x minus 1. All right, now one thing to note, you can actually just graph immediately from point slope form. In fact, I actually recommend it because it's just right from the get-go, you know, this is the information to use. And just in case you do mess up on your converting to slope-intercept form, you may be plotting the wrong line. So I would just say plot from point slope form right from the get-go. So from 1, 2, that means right here is my starting point, and then I'm going to do a slope of 4/3. So there's the next point. And boom. So there's the parallel line. So we know these are parallel based on the slopes. All right, so now I'm going to go ahead and finish and write this one in slope-intercept form because I still got to finish converting. All right, so I'm going to distribute. So I have y minus 2 equals 4/3 x minus 4/3. Wow, this is already gross. All right, so now I'm going to add 2 on both sides. Yeah, this is gross. So 4/3 x minus 4/3 plus 2. So I want to be able to combine 4/3 and positive 2. So I need a common denominator. So I'm going to go ahead and write a common denominator of 3. So I'm going to leave 4/3 alone, plus over 3. So if I'm going times 3, 2 times 3 gives me 6. So that means my new numerator is 6. And I'm going to combine 4/3 and 6/3, which means my equation here is y equals 4/3 x plus 2/3. So kind of referring back to what I was saying earlier, your slope-intercept form may not be the best equation to graph from. So if you can see here, we'd have a y-intercept of 2/3, which on the equation, on the graph, you can see that it doesn't pass through the y-intercept at a pretty point. So it's actually better to plot from point slope form. But I don't recommend waiting until slope-intercept form. Plot directly from point slope form. All right, so now we have the upside down t, which means we want perpendicular. So my original slope is 4/3. So now my perpendicular slope is the opposite reciprocal. So flip the sign, flip the fraction. So we're going to go to negative 3/4. So once again, start with point slope form. So we're going to have y plus 8 equals negative 3/4, then x plus 3. Okay, so distribute. Wow, these equations are actually really gross. So y plus 8 equals negative 3/4 x minus 9/4. Now I'm going to subtract 8 on both sides. So I make this equation 10 times worse. So y equals negative 3/4 x minus 9/4 minus 8. This is where you start crying because this equation is so disgusting, but everything's fine. Negative 3/4 x minus 9/4 minus, so I'm gonna get a common denominator of 4. So 8 times 4, which gives you 32. So now y equals negative 3/4 x minus 41/4. Wow, this is truly awful. But there you go. So that's gross. It's about negative 10-ish. So, all right. I'm going to plot from point slope form. So, but from negative 3, negative 8. So 1, 2, 3, 1, 2, 3. So right here. So it actually crosses through the original line. So I can't actually go down 3 and over 4. So I need to go the other way. So 1, 2, 3, 1, 2, 3, 4. So there's the up 3 and left 4. Yeah, so this equation, technically the y-intercept isn't even on the graph. Boom and boom. Boom. All right, so there's our perpendicular. So you don't have to if you don't want to. I just do because I'm a math person, I'm used to it. So there's the perpendicular signs, and then I know these are parallel.